Okay, for question 3 of this revision lecture, okay, for part 1, we are actually given that we have an equation, okay, with a mixture of x and y, x squared minus 6xy plus 2y squared minus 20y equals 0. We are supposed to find dy dx in terms of x and y. So what we are going to do is we are going to do implicit differentiation. So equation x squared minus 6xy plus 2y squared minus 21 equals to 0. So if we differentiate implicitly with respect to x, the left hand side will be 2x. Now because there's a combination of x and y, so we have to use product rule. Hold the first, differentiate the second, plus hold the second, differentiate the first. This one will be 4y, then we have to differentiate the y, giving us dy dx. 21 is actually 0, then the right hand side is actually also 0, okay, because it is a constant. So what we're going to do is we are going to actually collect all the dy dx together. And we are going to make dy dx the subjects, giving us this as the answer. Okay, tidy up a bit. We actually have 3y minus x over 2y minus 3x. And this will be the expression for dy dx. For the second part of the questions, now we are actually given that we have a curve with this equation, and please note that this equation is actually the same as what we are actually given in part 1. And now we are actually supposed to find the coordinates of each of the point at which the tangent is parallel to the line y equals to 2x plus 1. Please take note that since it's parallel, the gradient of the tangent that we are going to find, the gradient at the points that we are going to find should be equals to the gradient of this line here. And since we all know that the gradient of the line y equals to 2x plus 1 is actually 2, the strategy will be definitely making dy dx equals to 2, and hopefully, or we are supposed to actually get a relationship between y and x. And after we get a relationship between y and x, we will actually then sub it back to the original equation to find the coordinates that we need. Okay, so for part 2, this is dy dx, and we, as we discussed just now, we will actually set dy dx equals to 2. So a bit of algebraic manipulation, what we are going to get will be, okay, y equals to 5x. Now after I get the fact that y equals to 5x, please take note that we already know that the point that we actually want will look something like this. Okay, because the coordinates, if we know the x coordinate, then the y coordinate based on this equation will be definitely 5x. Okay, so the coordinates that we are looking for will look like this form. So as we discussed before, how to actually get the x coordinate of these points that we actually need, we'll actually sub this condition back to the equation of the curve. So the curve actually is x squared minus 6xy, so the y will be replaced by 5x, and plus 2y squared, the y again will be replaced by 5x minus 21 equals to 0. So if I have x squared, 30x squared, 50x squared minus 21. Okay, so continue with the working. What I will be having will be 51 minus 30. So simplifying, I will have 21x equals to 21. So x squared will be equals to 1. So x will be equals to plus minus 1. And hence the coordinates of the point that we are looking for is 1, 5, minus 1, minus 5. And this will solve the question.